Welcome to the Explainer. Today, we're going to pull back the curtain on a really powerful tool that economists use to make sense of the world, the index number. You might not know it, but it's the secret sauce behind some of the biggest headlines you read every day.
So you see this kind of headline all the time, right? But have you ever really stopped to think about it? How can the prices of millions of different things, all changing constantly, get boiled down to just one single number? Well, let's break down how it's done.
I mean, think about it. Every day, the price of gas, groceries, coffee, you name it, it's all going up or down. To get to that one inflation number, economists need a way to track the overall change for a whole bunch of items at once. And the clever tool they use to do this is called an index number.
Okay, to really understand how these powerful indexes work, we have to start at the very beginning with the most basic building block. The simplest kind of index out there is something called a price relative. It sounds technical, but it's not. All it does is compare the price of one single item, today, to its price at a fixed point in the past. And that starting point, we just call that the base period.
Let's use the price of gasoline to make this real. We're going to set our base period to the year 1990, back when a gallon of gas cost you about $1.30. And the formula is super straightforward. You just take the price in whatever year you're looking at, divide it by the price from your base year, and then multiply the whole thing by 100. This just turns it into a nice, clean number where the base year is always equal to 100.
So for 2005, we'd take that price of $2.27, divide it by our 1990 price of $1.30, and multiply by 100. And we get 174.6. All this means is the price in 2005 was 74.6% higher than it was back in 1990. Pretty easy, right?
But this is where things get a lot more interesting. A price relative is great for one item, but what happens when we want to track something more complex, like the entire cost of driving? Because that involves way more than just gas.
Right. To get a true picture of driving costs, you've got to think about more than just fuel. You've got oil changes, you've got new tires, and of course, you have car insurance. So how do you possibly combine all of those different price changes into one single, meaningful index? Now, your first instinct might just be to add up all the prices in 1990, do the same for 2005, and then compare the two totals. It seems logical.
And if we do that, the math tells us our costs went up by about 17%. But here's the thing, that number is deeply, deeply flawed. It's actually hiding the real story.
And here's why it's so wrong. The problem is that huge $820 price tag for the insurance policy, it completely drowns out the price changes and everything else. It gives the insurance price way, way too much importance in our calculation.
So the crucial insight here is that not all expenses are created equal in our budget. We have to find a way to account for how much we actually use each of these things. And this is the big breakthrough.
And that brings us to the real hero of our story, the weighted index. Instead of treating every price as equally important, it gives more weight to the items based on how much a typical person actually buys. So how does it work? Well, let's just break it into 4 simple steps. First, you get the prices, just like before. Second, and this is the key part, you figure out the typical amount you'd use in a year. Then, you just multiply each item's price by its quantity. And finally, you sum up the results and compare them. And this right here is where our whole perspective changes. Think about it. A typical driver might use 1,000 gallons of gas a year, but they only buy one insurance policy and maybe 2 tires. These usage numbers, these are going to be our weights. And the result is, well, it's dramatic. The moment we apply those weights, the story completely flips. The weighted index shows the cost of driving actually shot up by 49%. That's nearly 3 times what our simple first guess told us. This is a much more accurate picture of reality. So now that we have this incredibly powerful tool, let's see how it's used in the real world to understand one of the biggest economic forces of all, inflation.
And this brings us to the most famous weighted index there is, the Consumer Price Index, or CPI. It's basically a massive version of our driving cost example. It tracks a huge market basket of over 400 things a typical consumer buys. We're talking food, housing, haircuts, movie tickets, everything. When you hear the news talk about inflation, this is the number they're talking about.
And with the CPI, we can do some really cool analysis. Take a look at this chart. It shows the average hourly wage for workers between 1998 and 2002. At first glance, looks pretty good, right? A nice, steady climb upwards. This is what economists call the nominal wage. It's really just the dollar amount you see on your paycheck, without any other context. But it doesn't tell you what that money can actually buy. Now, watch what happens when we use the CPI to adjust those wages for inflation. This process is called deflating the data, and it lets us see the real story. And what we find is pretty shocking. This new line, this is the real wage. It represents your actual purchasing power. And you can see that even though the nominal wage was going up, the real wage, what people could actually afford, barely budged at all. They weren't really getting ahead, they were just keeping up with rising prices. That's the truth that deflating the numbers reveals. So in the end, index numbers are kind of like a pair of X-ray glasses for economists. They let us see past the surface numbers to understand the real trends in our economy. And it makes you wonder, doesn't it? What other numbers in our daily lives are hiding a much deeper story that only an index could reveal?